Hey guys, Mr. Backwork here. In this video we're going to look at the order of real numbers and using interval notation. The real numbers are ordered, meaning that we can use different inequalities to compare values to one another. So if we take a look at a number line, I'm going to put 0 here somewhere in the middle. We know that the numbers moving to the right of 0 gradually get larger. Those are where our positive values are located. And if we start working our way to the left of 0, that's where our negative numbers are. Okay, we can use this order to compare different real numbers using some inequalities. So if we were to look at numbers going to the right, like I said, those are getting bigger. So if we looked at 3 compared to negative 2, 3 is further to the right along our number line, meaning that 3 is a bigger value than negative 2. So writing that out as an inequality, we can say that 3 is greater than negative 2. Now we could write that the other direction as well. Because negative 2 is further left on our number line, that means that it's smaller than 3. So it would be true to say that negative 2 is less than 3. Now here we were talking about specific values on our number line, 3 and negative 2. But we can also use inequalities to talk about different intervals along our number line. So what we're going to do is look at a couple of examples of inequalities that represent intervals along our number line. We're going to interpret what those things mean, and then we're going to look at them visually by graphing them out along our number line. So as we're looking at our first example, we're given the inequality x is less than 3. So what we're looking for is all of the numbers that will satisfy this inequality. And since we're talking about numbers that are less than 3, any number that's smaller than 3 will work. So 2 would work, 0 would work, negative 300 would work. All of those numbers are smaller than 3, so they satisfy the inequality. Now, graphically on our number line, what I'm going to do is first place 0. And it doesn't really matter where you put 0, it's more so just so that we can reference where 3 is located. So I'm going to throw 0 here somewhere along the middle, meaning that 3 would be 3 spaces to the right of that. Now, graphing out this inequality, we're going to start at 3. Okay? Now, what I want you to notice is that this inequality is just a less than. It doesn't have the equals to portion underneath it, meaning that 3 is not included in this interval. Anytime we're graphing out an interval where the end value is not included, we use parentheses. Here, since we're using 3 and then the numbers that are less than 3, I'm going to use a right set of parentheses to show that this 3, this end value, is not included. Now we want all of the numbers that are less than 3, so all of the numbers that are to the left of 3. So I'm going to draw a line along my number line here, and I'm going to put an arrow on the end to show that that line would keep extending along our number line, including all of those values that are to the left of 3. Now in our second example, we've got a double-sided inequality. It says that negative 1 is less than x, which is less than or equal to 4. So this means that we want all of the x values that are between negative 1 and 4. The negative 1 is not included in the interval since that inequality does not have our equals to line underneath it, but the 4 will be included because we do have our equals to line there. Again, I'm going to place 0, so somewhere in the middle here is 0, meaning that negative 1 would be just to the left of it. Now, negative 1 is not included in the interval, so I'm going to put a left parenthesis at negative 1. Now, as we look at 4, 4 is included in the interval, so this is going to look a little bit differently. Instead of using parentheses, we're going to use a square bracket. So I'm going to put a right square bracket along 4 since that value is included. And then we want all of the numbers that are between negative 1 and 4. So I'm going to draw my line going between those two grouping symbols, my parenthesis and my square bracket. Now we might also be given a verbal description and want to write out what the inequality would be and then graph it. So that's what we've got going on here in this example. The first example says that we want all the real numbers that are between negative 4 and negative 0.5. Because we've got two values that we're dealing with, we're going to have a double-sided inequality, and those values are going to represent our end values. So we're going to have negative 4 on one side, and we're going to have negative 0.5 on the other side. And we want all the real numbers that are between these. So our x value is going to be somewhere in the middle. It doesn't say that the end values are included. It doesn't say that x could equal negative 4 or that x could equal negative 0.5. So what we're going to do is use a couple of less than symbols in here to write out our double-sided inequality. Then we can go over to our number line and graph this out. So I'm going to say that 0 is about right here, so negative 4 would be 4 spaces to the left. Now as far as negative 0.5, that's going to be halfway between 0 and negative 1. So as we're looking at graphing this out, I'm going to put a left parenthesis at negative 4, and I'm going to put my right parenthesis about halfway between 0 and negative 1. And then we want all the numbers that are between those values, so I'm going to draw my line going between my parentheses. Now in our second inequality, it says that we want all of the real numbers that are greater than or equal to 0. So here we've got one end value. Now in this one, it does say greater than or equal to. So I'm going to use that symbol. Okay, we want x values that are greater than or equal to 0. So if we go over to our number line and we place 0, 0 is included because we've got our equals to line on our inequality. I'm going to put a left square bracket at 0 since that's the smallest value and we're working up from there. So then I'm going to draw my arrow or my line going to the right since we want all of those numbers that are greater than 0. Now we're going to look at things called bounded intervals, and a bounded interval is just a double-sided inequality. So something like 2 is less than or equal to x is less than or equal to 5. We've got two endpoints, so our interval is bounded by those endpoints. And what we're going to work on doing with these bounded intervals is writing them out in interval notation. Now when we were graphing intervals, we used parentheses to show that the end values were not included. And we used square brackets to show that the end values were included. And we're going to use similar notation when we're writing inequalities out as intervals. So if we've got an inequality where a is less than or equal to x, which is less than or equal to b, each of those end values are included. So we're going to use square brackets when we're writing this out. And to write out this interval, we just use those end values. So we're going from a to b, and the end values are included, so we get square brackets around those. Now if these end values were not included, if we didn't have the equals to lines, like a is less than x, which is less than b, then we would write it out using parentheses. So again, we're going from a to b, but this time the end values are not included, so we enclose that with parentheses. We could also mix these together, like if we had a is less than x, which is less than or equal to b. The a is not included, so the a would get a parenthesis around it, but the b is included, so that one would get a square bracket. This could also go the other way. We could say that a is less than or equal to x, which is less than b. So that one, the a is included, so the a gets a square bracket around it, but the b is not included, so it gets a parenthesis around it. Now there are also unbounded intervals where we've only got one end value, so something like x is greater than or equal to a. We can still write this out using interval notation. Since a is the smallest value, it would go first. Now there is no bound as to how big x can be, so this actually runs out to positive infinity. Just like we were doing before, if an end value is included, we're going to use square brackets. So here a is included, so it gets a square bracket on it. Infinity can never be included since there really is no end to where infinity is, so infinity will always get a parenthesis around it. Now if we didn't include that a value, so x is greater than a, similar to what we were doing before, we're going to use a parenthesis here, and again we're going to run out to positive infinity, so that also gets a parenthesis. Now if we use less than, if we had x is less than or equal to b, here b is the biggest number, so it's actually going to be the second number that we write down. The smallest value, well, I guess there really isn't a smallest value since we're looking at all of the x values that are less than b, so that's going to run down to negative infinity. And again, infinities always get parentheses around them. Here b was included, so it gets a square bracket. Or we could write this out where b is not included, so we've just got x is less than b. So similarly, we're going to run from negative infinity to b, but both of these are going to get parentheses around them since neither one is included. So here we're going to look at a few examples where we convert back and forth between intervals and inequalities. So in our first example, we've got the interval that runs from -6 to 3. -6 is included, but 3 is not. We want to take that and turn it into an inequality. So we've got -6 on the left-hand side, we've got 3 on the right-hand side. X is between those. We do want to include the -6, so we're going to do less than or equals to, but we don't want to include the 3, so we're just going to do less than there. In our next example, we've got the interval that runs from -infinity to -1. Here, this one's unbounded, so we're only going to have one endpoint. The endpoint is at -1, and we're going from -1 down to -infinity, so we want all of the x values that are less than -1. In our final example, we're given an inequality, and we want to write it out in interval notation. We've got two endpoints, so we're going from -2 to 3. Each one of these endpoints is included, so they both get square brackets around them. That's going to be it for this video. Thanks for watching.